Our project is the Data Congressional Challenge. That is the client side part of it. We have a work with two teams that goes ahead and we're able to produce a we worked with two teams to be able to produce yeah. We were able to, our project, here.
Yeah, so we were the Congressional Data Challenge. We worked with two teams in order to produce both visuals and a data side to campaign contributions. We work with Code for San Francisco, which is a group of volunteers that work on various projects for real-world issues.
They also focus on civic technology, which is using information technology applications to solve real-world problems.
My name is Laura.
I'm Pete.
I'm Philip.
And I'm Josh. Many of you may know that campaign contributions can play a large role in elections. The majority of campaign contributions comes from just 1% of the population, yet these elected officials represent 100% of the population. Are they working for what's best for the population as a whole, or that 1%? Our overall objective is to give more transparency into campaign contributions. Our first main objective is to analyze campaign contribution data in order to create a model that can test feature effectiveness. Our second goal is to create easy to understand visualizations that the average voter can interpret and become a more informed voter.
Our approach was to merge campaign finance data with election result data, and then to model which factors have the largest influence, and finally to use that model to predict election winners. We used mode analytics to do feature analysis and data analysis and feature engineering. We used Python, scikit-learn, and Jupyter Notebook to create our model, and we used Trello, GitHub, and Google Hangouts to collaborate with the rest of the Code for San Francisco team.
So some of the solutions we came up with was to analyze the characteristics of finance contributions. And we did that using machine learning, one-hot encoding, and dimensionality reduction of our data set. We also created a few machine learning models to analyze these feature effectiveness. So one that really worked out well was a tree, a support vector machine, and ensemble methods. And we also created an algorithm for name matching because in two different data sets, there were different names for different candidates. For example, Jerry Brown and Gerald Brown. So here's some pictures of our models. So the first one right here is an ensemble learner using a decision tree, and it predicted the correct result 93% of the times. And then we also used the support vector classifier, and it predicted 84% of the time the correct outcome of the election.
Our deliverables, we have a documented functional pipeline. A pipeline is a blueprint that others can reproduce to our work. We have stored and saved the SQL queries on mode analytics. We have generated data for the other team in the form of a CSV file to populate their Django database. We did feature exploration that identified characteristics to draw correlations. And the significant result was the average campaign contribution per election cycle for each candidate in California's general election from 2010 to 2016.
The name matching works by taking raw candidate names, converting them into a uniform format, and then creating name to ID pairings from that.
We also delivered a Jupyter Notebook to Code for San Francisco, which included the machine learning models, the name matching algorithm, and explanations, so it is all useful. We wanted to give a big thank you to our mentors, Eric and Vince, and also our faculty mentor, Professor Brentz.